Hi, I'm Louis Baarda with Farming Smarter. We're here in Enchant, Alberta, and today we're getting ready to set up and install some sensors for a variable rate irrigation project. So one of the things that we found with irrigation and variable rate irrigation is there's a lot of pieces that have to come together for it to work properly. And a big piece to that is knowing what's happening in the soil so that we can respond to it appropriately with our irrigation. And that's kind of the goal with this project. I have Dr. Mark Johnson here with Ensemble Scientific, a partner in the trial. He's the scientific expertise behind the sensors, the connectivity, and a lot of that stuff. So we're hoping to be able to install some sensors, make sure they're telling us what's happening in the soil, and get a start on having them communicate with the pivot center so we can use that to direct irrigation. So maybe you can share a little bit, Mark.
Absolutely, happy to. Yeah, so we're here in this field with the center pivot, which will go around, and the ground is slightly rolling. There's not a whole lot of relief, but there's enough to cause changes in the way that water will move through the soil. And then through soil sampling, we also see that there's changes in soil texture. And so that affects how strongly the water is held in the soil, how available it is to the plants. And so we're planning to put out a pretty dense array of soil sensors to capture information for what's happening in the soil, make sure that that information is communicated to the producers to be able to make informed decisions and communicate that into the VRI system so that it can put the right amount of water into the right location, keep all the plants happy and healthy, and use the appropriate amount of water and that sort of thing. And with Ensemble Scientific, our goal is to design systems that are as easy to use as possible. So you put the soil sensor in the soil, it can start transmitting data into the cloud, and then once you have a number of these sensors, then we can make maps from that and communicate those maps into the VRI system to help with the dynamic programming and make adjustments based on how much water is in the field at different points, as well as the upcoming forecast to know, is it going to be a hot and dry day? Is it going to be very windy? That sort of thing that could affect the system efficiencies, as well as how much water might be needed to be put down to keep the crops healthy for the rest of the growing season, and particularly the week ahead.
So one of the big considerations that we've gone through in putting this project together is consulting with farmers and talking with them about exactly what makes sense for them. And we've settled on starting with a semi-autonomous system, which means that we're going to have a system that's going to be able to provide a recommendation to the farmer, but the farmer, at least at this starting point, will be able to say, hey, this recommendation makes sense. We give it the go-ahead. The pivot will irrigate according to that. Or the farmer can say, you know what, we have some field operations planned this week. We're planning to do some fungicide application, some spraying, what have you. Let's pause it for now and shoot us another recommendation in a couple of days. So it's kind of trying to integrate all the science and all the autonomous piece with what the farmer needs to properly manage that site.
That's right, and we should also mention our other partner in this is LiteFarm, which is a farming management platform that can help with the visualization and the notification systems.
So yeah, stay tuned. We'll be updating you throughout the season as this project progresses.
How many sensors would you put in a field this size?
So that's a Mark question. That's a good question.
Yeah,
actually.
In some ways it's the more the merrier, but from the producer's perspective, you would want to put in as few as is necessary.
Yeah.
So that might be maybe 2 different depths at a couple different locations in the field. Here we're doing this kind of proof of concept, and we're going to do an overabundance of sensors just to get all the information together that we can, see how everything is really functioning. So we're looking to put out maybe up to 150 sensors in this field for this project.
And the idea being that if we find 2 different sensors are responding the same way to water and to environmental conditions, then those are duplicates. And moving forward after the proof of concept, we would reduce the total number of sensors accordingly.